गुड मॉर्निंग। अभी हम बात करने वाले हैं कुछ प्रॉब्लम्स की जो हैं नर्स्ट इक्वेशन पर बेस्ड। इसके अंदर हम बात करेंगे वी हैव टू कैलकुलेट द ईएम ऑफ द सेल। इफ़ वी टॉक अबाउट द नर्स्ट इक्वेशन, जो कि हमने अपने एक लेक्चर में बात भी की है, तो वहाँ पर जब भी हम नर्स्ट इक्वेशन की बात करते हैं तो वी राइट इलेक्ट्रोमोटिव फोर्स ऑफ द सेल इक्वल टू that becomes the standard electrode potential minus if the condition is standard, तो in that case हम यहाँ पर सिर्फ लिखते हैं 0.059 अपॉन नंबर ऑफ इलेक्ट्रॉन एंड यहाँ पर आ जाएगा हमारे पास log द कंसंट्रेशन जो भी रिएक्टेंट प्रोडक्ट जो भी प्रोडक्ट में फॉर्म हुआ है आयन, और यहाँ पर आ जाएगा जो भी हमारे पास रिएक्टेंट में मौजूद था. Okay, now in this cell what you see here, it is the concentration of the ions given. Alright, this reaction could be take place like this, like the zinc metal, it is one of the oxidation half cell. इसमें क्या हुआ होगा कि जो हमारा जिंक है that has been oxidized to zinc 2 पॉजिटिव और इसने 2 इलेक्ट्रॉनों को रिलीज़ किया होगा. And in reduction half cell, the nickel itself acquired these electrons and form nickel metal. Let me correct it. Nickel metal that becomes solid. So the process somehow taking place कुछ like this. Alright, अगर हम इस क्वेश्चन को सॉल्व करें तो उसके लिए हमको ज़रूरत पड़ेगी इसके स्टैंडर्ड पोटेंशियल की. ऑलराइट, तो यहाँ पर हमने देखा कि हमारे पास जो ऑक्सीडेशन है दैट ऑलवेज टेक्स प्लेस ऑन एनोड, और एनोड हमारा रहता है हमेशा लेफ़्ट साइड में, ठीक, किसी भी इलेक्ट्रोकेमिकल सेल में, और ये रहा हमारा कैथोड, और कैथोड रहता है हमेशा राइट साइड में. ऑलराइट, तो अगर हम इसके सेल को फॉर्मेशन करें या सेल को बनाने की कोशिश करें, देन वी फाइंड आउट लाइक कि सपोज these are two containers and in both the containers you see, suppose it is a zinc electrode and now here it is a nickel electrode. Alright, and all of them has a solution. It has solution of nickel, and this one has the solution of zinc sulfate. Alright, when these both the things, or both the electrodes when connected by each other, then the electron flow from anode to cathode, or as an electron flow from anode to cathode, then the current will flow from cathode to anode. It has a negative charge and it has positive charge because the electrons are flowing from negative to positive. Alright, in this cell, when this metal electrode dissolves, it do something like that, like it releases electrons like these. Zinc metal release electron and form zinc 2 positive and 2 electrons. ठीक, these electrons move to electrode just because of that it has the negative charge, and these negative charge through this wire travel to the cathode because it has positive charge. Likewise, in this electrode solution there are a lot of the nickel ion, and these nickel ions accumulate this electron from this cathode and form nickel metal. In the same scenario, we are seeing कि here deposition is taking place. deposition is taking place. But here dissolving is taking place. The metal ion is being thinking, or it is thickening. Thickening of this cathode taking place. In this case, it is being thin with every passing second or every passing electrons. Alright, somewhat the reactions go through like that. Alright, now we have to see there is one more thing that we really need to mention over here, and that is, it is called the salt bridge. It try or make the both the solution neutralize, keep the both the solution neutralize. We will discuss about it, even in the past video we discussed. Now we have to understand the value of the E naught cell. E naught cell is calculated like E cell equal to E right side minus E left side. Standard value. These are called electrode potentials or reduction potentials of the cell. At the right side there is nickel, that is minus 0.44, and at the left side there is 0.76, that is a electrode potential of zinc, and it has also the power the sign negative. Then it becomes 0.44 minus minus plus, and it becomes 0.76. Okay, when we calculate the value, it comes out to be like it becomes when you subtract 4 from 6, it becomes 2 and 3.0. It is the value of E cell that's taking place in this reaction. Now move to the next thing, that we know the concentration of both of them. It is the concentration of whom? Zinc in molar, and it is for the nickel. When we put the value in this equation, we find कि E cell equal to, at the E naught cell we can write the value of the these we have just calculated. It is 0.32 minus 0.0. To make it more calculatable, we write 6 at the place of, we just making it round up like being 9 2, or here we can write log, and the value of the zinc, that is given 0.1, and the value of nickel, that is given like 3.0. All right, in such situation what we really need to do, we have to calculate the values of the log. All right, to calculate the value of the log, we do what? Like this. All right, now we know the formula of the log. If something is written like 0.1 and 3.0, we make it, and it becomes the log 1 upon 30. Now we can also write it log 1 minus log 30, and itself it becomes 0, the value of 0, and now we have log 30. Alright, we can divide this number, like we can set like log 3 into 10. Alright, it becomes minus log 3 plus log 10 according to the formula. Now we know the value of log 3 is 0.4771, and the value of 10 is 1. Right, then the overall value becomes minus 1.4771. It is the value for the log. Now put the value over here. To calculate the E cell, we have used 0.32 0.32 minus 0.06 upon 2 into minus 1.4771. Good to know that. Alright, अब now put the value 3.2 minus minus become plus 0.06 into 1.4771 upon 2. Take their values in the control and what you see, it becomes 0.03. Now 0.32 plus, when you calculate all of them, we come to know like it becomes, after 2 points it is 2, after the multiplication we have 3, 7 times to 1, 2, 3, 2, 4, 1, 4, and it is after the digit 1, 2, 3, 4, 5, 6. Here after the 6 digit there will be point 1, 2, 3, 4, 5, 6.0, and they both the value will be added, so it comes out 0.364313. it is the EMF of the cell in case of that. Alright, it is the value that is called the EMF, and the final value of EMF, or we can say like E cell, will be 0.36 volts. That's the answer. Alright, now move to the next question. That is also very easy, by the way. Here you see the next question. The only change is about this. It is one of the interesting question actually. The molarity is given right now. It's changed a little bit, but that is also a symbolic representation. So first of all, when you see the difference in the number of electrons, like here the Zn and Ag plus reaction is taking place and it is forming Zn2 positive plus Ag solid. Here it is, you have to change the equation in case of that, like at cathode somewhat reaction is taking place. Ag positive acquiring 1 electrons, let me correct it, 1 electron, and forming Ag solid. But at anode, that is a zinc metal, the zinc metal is solid, losing 2 electrons. Over here it is losing 2 electrons, like we can write losing 2 electrons and forming ion. To make the number of electrons equal, what we have to do, we have to multiply it with 2 and multiply these with 1, because it has 1 electron, then the cross multiplication will take place, and the final equation will be Zn plus Ag2 positive, Zn Ag positive, reaction will take place, and here it is zinc 2 positive and Ag solid. Number of atom will be here 2, and the 2 because the 1 electron only satisfy the 1 atom and the 2 electron will satisfy the 2 atom. If we write the equation in such case, we have to use the principle like E cell equal to E naught cell minus 0.06 upon number of electron, that is 2 we know right now, and the log value of the zinc Zn and the value of the silver. So right now you have to write Ag ka whole 2, Ag ki power 2. This is just because of this stoichiometry. If the stoichiometry has been raised, then you have to use this formula at this place. Here the electrode potential of the silver, like this cell, we have to calculate. For the silver we write Az positive to Ag, and for the zinc that's become Zn2 positive to Zn. Now let's put the value over here. For the zinc we use 0.80 and the electrode potential of the zinc is 0.76. When we put the value over here, what we see, it becomes 0.80 positive 0.76. It comes out the 5.1 volt E electrode cell value. Now we put the value over here like in the nerst equation, and for that we need the molarity. Then the molarity is given over here, like it's at 0.2 molar for the silver and it is 4 molar for the zinc. When we put the value in this equation, what gonna happen, that let's see that. Here the E cell इक्वल टू ई नॉट सेल की जगह हम रख देंगे 1.56 माइनस 0.06 अपॉन 2 एंड द वैल्यू ऑफ लॉग ऊपर आता है जिंक, तो दैट कम्स आउट टू बी लाइक वी कैन राइट ओवर हियर डायरेक्टली वैल्यू, एंड द वैल्यू इज 4 एंड द डाउन स्टेयर इट इज़ 0.2 का square, that is the stoichiometry. Alright, it becomes 0.03 when we divide and comes out to be 1.56 minus 0.03, and it becomes like we convert this value like log 4 upon 2 into 10 की पावर minus 1 की पावर 2. Alright, it comes out 1.56 minus 0.03 and the values become somewhat like log 4 upon 4 into 10 की पावर minus 2. It will go up 4 divided by 4 and it comes out 1.56 minus 0.03 and it comes out log 10 की power. When this value go up it becomes 2. In that case the value comes out 1.6 minus 0.03 into 2 और log 10 की value हो जाती है 1 because the power always comes upward. Alright, here it becomes 1.56 minus 0.06 and when we add them the answer comes to 6.1 volt EMF or also E cell. It is the answer of this question.